Hello, I'm Brian Farrell, and welcome to PACE IT's Introduction to IPv4 Part 1. Today I will be introducing you to IPv4, and then I will be talking about IPv4's address classes. There's a whole lot of material to cover, so let's go ahead and begin this session. And I'll begin by introducing you to IPv4. Internet Protocol version 4 is a binary addressing scheme that is used for networking. It was finalized as a standard in 1981. Now, IPv4 is the most common and popular network addressing scheme that is out there today. There is an issue with it, though. Because of its structure and the growth and popularity of the internet, most of the world has run out of assignable IPv4 addresses. But thanks to some forethought and some special mechanisms, it's still a valid scheme today. Now, IPv4 works at layer 3 of the OSI model. Layer 3 of the Open System Interconnection model is the network layer, and its major focus is on logical network and host addressing. IPv4's job is to provide the logical network and host addresses, and it does this extremely well. IPv4 is a 32-bit binary addressing scheme. The 32 bits are broken down into 4 octets, which can be represented by zeros and ones. Of course, that's what binary is. For human readability, it is represented in a format that is called dotted decimal. There are theoretically 4,294,967,296 possible individual IPv4 addresses. Binary numbering uses base 2 counting, which means that every bit that is present represents an exponential growth in the value that is being represented. So with IPv4 being a 32-bit number, the possible maximum value is equal to 2 to the 32nd power, which is why there are over 4 billion possible IPv4 addresses. Now let's move on to IPv4's address structure. Some of the bits make up the logical network address. Think of your own physical address. And some of the bits make up the logical host portion. Think of a letter that is addressed to you at your physical address. Now, each address in IPv4 needs to be unique if routing is going to occur. Now, a device called a subnet mask is used to determine which portion of the IPv4 address is for the network and which part is used for the host. So now let's talk about the subnet mask. It is also a 32-bit binary number. It can use 2 methods of being represented, dotted decimal like a normal IPv4 address, and the CIDR format, classless interdomain routing format. If the subnet mask is used, it's applied bit by bit from left to right. And here's what I mean by that. The subnet mask 255.0.0.0 is applied left to right to the IP address. By the way, if that was represented in CIDR, that 255.0.0.0 would be represented by a /8. Any portion of the IPv4 address that is covered by the ones in the subnet mask make up the logical network portion of the address. The other portion makes up the host address. So with that IPv4 address that we have there to the right, the network address would be network 24, and the host address would be 113.185.118. Now that we have that covered, let's move on to IPv4's address classes. IPv4 has been divided into classes of addresses. There's Class A, Class B, Class C, Class D, and Class E. Now you only really need to know about classes A through D, so let's cover those now. Now, a Class A address always has a subnet mask of 255.0.0.0. This gives us 256 possible Class A networks. The first octet on the left always begins with a 0. So that means that the first bit of the left-hand octet always begins with a 0. That gives us a possible address range of 0.0.0.0 to 127.255.255.255. Then there are Class B addresses. These always have a subnet mask of 255.255.0.0. This gives us 65,536 possible Class B networks. The first octet on the left of a Class B address always begins with a 10. So the first two bits are always 10. This gives us a possible address range of 128.0.0.0 up to 191.255.255.255. Then there are Class C addresses. These always have a subnet mask of 255.255.255.0. This gives us over 16 million possible Class C networks. The first octet on the left always begins with a 110. So the first three bits of the left-hand octet are always 110. This gives us a possible Class C address range of 192.0.0.0 up to 223.255.255.255. Now we're almost done, but let's talk about Class D addresses. Now these do not have a defined subnet mask. That's because they are a special class of addresses. Specifically, they're used for multicast network transmissions. The first octet on the left always begins with a 1110. So the first four bits of that left octet are always 1110. It has a possible address range of 224.0.0.0 up to 239.255.255.255. Now, I did mention briefly Class E addresses. Currently, those are just being used for research, so you don't need to know about those at this time. Now, that concludes this session on the introduction to IPv4. I started by introducing you to IPv4, and then I moved on to IPv4's address classes. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon.